ladies and gents. Hey, I'm recording right now. Ladies and gents, section 7.6. We're going to solve radical equations. We've actually already been exposed on solving radical equations. We've already seen this in action, but we're going to see more of it, more technicalities, how solutions may exist, may not exist, and so on. All right. Here we go. First one, you already have it. Whoops. Hopefully we know, hey, got to subtract 2, get it to the other side. So we're going to talk about inverse functions, or inverse operations, I should be more specific. Inverse operations. The inverse operation of taking the third root is taking the third power. So we're going to take the third power on both sides. After we take the third power on both sides, those operations undo each other. So I can cross it out, because some of you guys are visual learners, and you physically have to cross it out so you realize, hey, I'm just left with an x on the left side, and then whatever negative 2 to the third power is. That means you take negative 2 times itself 3 times, giving us negative 8. And we check. Check it. Put negative 8, take the cubed root of negative 8, then add 2, see if you're equal to 0. You start undoing the problem. So, add 5 first. Divide by negative 1. And then we have to undo that square root by taking each side to the second power. One step, 4th root of x. I'm going to have to take each side to the 4th power. So x is equal to 81. Here's where we get into rational exponents, where we could raise each side to a reciprocal power. But we also have to recognize, hey, wait a second. I take this to the 1/2, but multiply by 2. I have to undo this multiplication by 2 first. Then you can raise each side to the second power. 1/2 to the second power, power to a power, you multiply those powers, this becomes 1. So x to the first power, or just x, is equal to 81. So again, we've got 5 times x to the 3/2 equals 40. I will need to divide by that coefficient. To get rid of this 3/2 power, I'm going to have to raise both sides to a reciprocal power. Oop, oop, oop. So raise each side to the 2/3 power. So power to a power, multiply those powers, you get x to the first power. Equal to, well, 8 to the 2/3. We should be able to do this without a calculator. So denominator becomes the index. We've got cubed root of 8 squared. This is one way of looking at it. So cubed root of 8 is 2, and then square that. All right, this is the next one. Raise each side to the 4/3 power. Okay, since this is practice, okay, power to a power, 3/4 times 4/3 becomes 1, so x to the first power. But practice, make yourself go through the thought process of, okay, 1/8 to the 4/3 power. How can I rewrite that? So cubed root of 1/8, you could take cubed root of 1 over the cubed root of 8. It actually becomes 1/2. So it becomes 1/2 to the 4th power. We're looking at an answer of 1/16. So put a star. Even roots will need plus or minus. But we have not had that so far because we have not had even denominators. And when I say even denominators, when we're raising it to a power, that's what we put into the problem. Notice how the original problem stayed with 3/4. We put into the problem, raising it both sides to the 4/3, because we had odd roots here, because the denominators were odd. I did not have to worry about the plus or minus. A word of caution to this tale. Now, so in this case, the radical's already put in, so I don't have to worry about the plus or minus. What do? I repeat, if the whole thing, the whole expression on one side is being square rooted, then you must square immediately both sides. Next problem, again, the entire expression on the left side is being square rooted. So in order to get rid of that, you've got to square both sides. And then subtract 1, divide by 2. Always check to see if I need to insert a plus or minus symbol. Did we ever insert a square root? The problem started out with the square root. We never inserted it. So therefore, we don't need to worry about a plus or minus, but we should just mentally check. 2 times 24, we're at 48. Add 1, you're at 49. Now take the square root, we're at 7. So with the next problem, in order to undo a cubed root, you got to take both sides to the third power. Here's the more advanced stuff. So, notice the expression on the left. It's got a square root. So to undo the square root, you still go with how to undo the square root. You square both sides. And then we're left with those expressions and solve from there. So for the check, if I put in a 4, square root of 7 times 4 minus 8, question is it equal to square root of 5 times 4? So go through that process. Square root of 28 minus 8, is it going to be the same as the square root of 20? And it should, because we get the square root of 20 on the left side, square root of 20 on the right side. Next problem. Let's always check to make sure it checks. So, when involved in the check, I'm going to write it out. So 3 times 5 plus 5. Is that going to be equal to the square root of 5 plus 15? So is the square root of 15 plus 5 equal to the square root of 20? And it sure is. So 5 is definitely the solution. Go on to the next one. Taking the cube. Ooh. Watch what happens live. So we do have a cubed root of an expression by itself. I am going to take the cubed root on both sides. I have a feeling we might have an error. Check your papers. We got to make sure that we also cube the 2. So 2 needs to be cubed. So we get 8, and then the cubed root of x cubed becomes x. Now getting your stuff together, 14 equals 7x, x is 2. we still need to check our answer. So to check my answer, cubed root of 2 plus 14, ask yourself, is it equal to 2 times the cubed root of 2? So cubed root of 16. If we were to rationalize 16, do we have a triplet? We do. We do have 2 cubed, so there would be a 2 as a coefficient times the cubed root of the 2.